So I thank the gentleman, and we're going to move to Mr. Foster of Illinois.
Well, thank you, and thank you, Mr. Chairman, for allowing me to sit on this committee hearing. I guess my first question is, assuming that ITER succeeds and that sometime around 2025, 2030, which succeeded everything, including DT, the DT program, what are going to be the remaining unsolved problems, A, to be able to design a production, something that is an energy plant? What's on the list of things that will be unsolved problems? And secondly, what will be needed to understand what the levelized cost of electricity from a tokamak of those dimensions might be? Those are the two things that have to succeed to make fusion succeed. Is it has to succeed scientifically and engineering-wise, and it has to succeed economically. And so what will be the unsolved problems in 2025 or 2030, assuming everything goes nominally? I'm happy to have, two can split it.
Yes. Okay, I do believe that the main problem which we'll have, okay, there is two main problems from my point of view. Once, the ITER will have been delivered is full demonstration that we could have, 500 megawatt coming out of the 50 megawatt we will put in. It is materials, okay? When we will have continuous production of plasma energies, with some energy flux, with high neutrons, flux, which are as large as 20 megawatt per square meter. When we know, for example, in many
that's the power density on the diverter, or not in
yes,
the whole?
Yes,
okay,
on
right.
the diverter. Okay. So how we could manage some materials which could be able to sustain such a flux continuously. And the second, we know if we want to take full advantage of the investment of an industrial tokamak with the superconducting coils, which could last for very long, because there is no real use with the superconducting coils, because there is no energy dissipation, as you know, and so it will be the remote handling. How could we change some of the piece, for example, the tiles which will be facing the plasma? How we could make all this remote handling properly done in such a way that, we could take the best investment and have a long lifetime expectation for the delivery. So in order to come to the point you mentioned about the economy, big investment, but if the operation cost and the lifetime of the equipment is very long, it will be quite economical process.
And are there actually design studies where you say, just, imagine that you're not making one of ITER, but you're making worldwide 100 of them? How cheap could you imagine making all the superconducting coils? How cheap could you imagine making all the different components? You can be optimistic there, but if you find that the levelized cost of electricity doesn't look attractive, then you have to actually step back and maybe reallocate between more adventurous but potentially cheaper ones and straight ahead with the current plan. And so what's the current state of knowledge of what the economics might be, just assuming everything works technically at ITER?
Okay, right now there is several studies. As we know, ITER is the first of a kind. And we have a lot of equipment around with diagnostics, with heating powers, the technology, and so on. So the people mentioned to me very recently that when we will be moving to a real industrial facility, maybe the cost will be down compared to the cost of the ITER facility.
Unquestionably, and if you tell me you are optimistic it will be the unit cost will drop by a factor of 5, it's not unthinkable, but then you still have to do the cost of electricity calculation and see if you're happy with the result. And I wonder if those sort of studies must have been done for different versions of fusion machines at different levels of accuracy. What's the current understanding for whether the ITER design point has a shot? I mean, that's the question I'm trying to get at.
From my point of view, all the studies I have seen so far, we expect that the cost of the electricity which will come from such a facility will be around, what we call 100 euro. I speak in euro, which will be $100 dollars, per megawatt, as you have now, for example, with some of the windmills or solar energy.
That's
so it will be comparable.
13 cents a kilowatt hour, right?
Yes.
Yeah. Stu, do you have anything to?
Maybe I agree with everything Dr. Begot said. I think for challenges, let me list three. I think one, in the plasma science, we have to learn how to hold the plasma in steady state persistently. ITER will teach us about that, but ITER will burn for about 8 minutes or so, and we need to learn how to have a burning plasma that lasts for months on end. That is, in part, a plasma science challenge, and there's research underway to accomplish that. Number one. Number two, as Begot said, there's the whole issue of materials research, both the plasma-facing component and the structural material that has to manage the neutron bombardment. And that's a set of challenges, and there are ideas how to meet those challenges. And third, while ITER is operating, we are working on how to make the reactor concept even more attractive economically. So ITER will teach us all about burning plasma science, and then maybe by the time we get that, we'll have evolved beyond simply duplicating ITER for a reactor. So we can take that burning plasma science, ideas that have been developed in parallel, and maybe have a more highly optimized reactor. On cost of electricity, over the years there have been the best engineering studies that could be done, taking the cost of materials, the cost of assembly, and calculating a capital cost and cost of electricity. They always come out to be competitive with base load power generation of today. However, projecting economics 30 years into the future is highly theoretical. We have an interesting data point with ITER, and we do ask ourselves the question, does the cost to construct ITER, is it consistent with the engineering calculations of what a reactor will cost? ITER is not a reactor, first of a kind, and so on. And at PPPL, we have the beginnings of a study to try to quantify that, try to quantify how much extra cost is in ITER, because it's an experiment, it's a first of a kind, internationally managed. And so we're in the process of trying to get financial, if you like, data from the ITER partners so we can quantitatively answer your question.
Yeah. Well, thank you. And that's very important to the strategic decisions that we're going to have to make. I guess at this point I yield back.
Bill, Yogi Berra said the problem with predictions is you're dealing with the future. So the gentleman recognizes the gentleman from Georgia. Barry, you're up.
Thank you, Mr. Chairman. Dr. Begot, you had mentioned in your testimony that not only is ITER building a first-of-its-kind reactor,